All right, we're going to take a look at 6.4. 6.4 has several different things in them, but they're all related. Ratios, proportions, and then proportional reasoning. The first thing we're going to take a look at is what a ratio is. All a ratio is a fraction. It's exciting, we've been working with fractions, right? So a ratio is written as A colon B, or for more practical purposes, we're going to be really using them for, we're going to write it as a fraction, A over B, and then we read that as A to B. Okay? There's a couple different ways to describe, or maybe I should say to talk about ratios. You can talk about ratios as a part to a whole, or you can talk about ratios as a part to a part. So for instance, if we were talking about the students in the class, and we're going to talk about grades, let's say. Okay, so if we had 15 students in the class, 7 of them make an A, then we can talk about the ratio as 7 to 15, which would be the number of A's to the number of students. Or if you want to talk about part to part, we can talk about the number of A's 7 to the number of people who did not make an A 8. So we can talk about the ratio as 7 to 8. So they mean different things, right? It means, you know, it depends on what you're talking about as to which one you would use. But there's two different applications for ratio. All right, so here's an example. This is the ratio of boys to girls in a class is 2 to 3. That may be the ratio of boys to girls on campus, I'm not sure. But the question asks us, what is the ratio of boys to all the students in the class? So what you're actually seeing here is you're seeing a 2 and a 3, and the 2 on the top is talking about the boys, right? And the 3 on the bottom is talking about the girls. But what you're asked to find is the ratio of boys to the whole class. Do you see the difference? Now, the boys part's the same. It's 2. But for every 2 boys in the class, how many girls are there? 3. So this whole class should be boys plus girls. That's 2 plus 3 for a total of 5. 5. So if you think about this in terms of percents or something like that, that'd be 40% in essence of the class would be boys and 60% would be girls. But the ratio of boys to the whole class would be 2 to 5. Now we're going to do the ratio backwards. Okay, so in this case, on example 2, we're told 3/7 of the class are girls. So in this case, we're actually given that the girls to the whole class is 3 to 7. And we're asked to find what the ratio would be of girls to boys. So what would the ratio of girls to boys be with those numbers? 3 to 4. So it would look like the fraction 3/4. And again, why? Well, because this class should be boys plus girls. And we already said that the girls is 3, right? What's missing would be a 4 to make this 7 at the bottom. It doesn't matter. You can write it either way. So did you guys grab your question? She said, do I want you to write it as a fraction or as a ratio, like a with the colon between them? You can write it either way. So if you like it with the fraction like I was using, that's fine. If you want the colon between, that's fine. If you want to put the 2 numbers with the word TO, 2 between them, that's okay as well. Those are all 3 equal forms for ratios. All right, however, when we get to proportions, you have to write your ratios as fractions because we're going to need to work with them in fractional form. So a proportion is a statement that takes 2 given ratios and has them equal to one another. Okay? And we have some theorems, in fact, quite a few theorems about proportions. So let's take a look at these proportion theorems. So theorem 620 says we've got some real numbers. We've got a couple of conditions that b and d cannot be 0, and the reason, of course, is because that would make denominators 0, if denominators are 0 allowed, right? And this is actually going to be true if and only if AD equals BC. And you can see that's doing this. This A times D has to equal B times C. So if the proportion works, then you can do cross multiplication and it will work as well. And they're equal. Take a look though at the other two. The other two are interesting. We still have the same sort of fraction forms, right? A over B and C over D, just like we did before. And this one says that if A over B equals C over D, that's going to be true if and only if B over A equals D over C. So what happened between this set of ratios and this set of ratios? We flipped them both upside down, right? So if I flip this one upside down and this one upside down, the ratio or the proportion, I should say, has to still hold. Make sense? But that should seem realistic because that means that A times D equals B times C, and then I'm back to this exact same expression I had before. So, okay. How about the 622? Well, again, it starts out the same way, right? I've got some conditions on what things can and can't be zeroed, and it all has to do with denominators. But I've got A over B equals C over D, another if and only if. This one says A over C equals B over D. So what happened this time? How did this proportion change from the first proportion? What moved? The B and the C. And what did they do? They just switched places, right? We flipped them. So these two right here, B and C, switched spots. But when they switched spots, this property up here, 620, still holds, right? Here's A times D. And here's B times C. Well, if that proportion holds, then I should have A times D equals B times C, and this should all still work. So what we've been told now is that you can flip the fractions both upside down, and you can also switch one of the diagonals, right? That's what that's saying. All right, and now we're going to do some proportions. Because Sarah wanted to, right? Okay, I want you to do proportions. All right, so we've got Jim. Jim found out that after working for 9 months, he had earned 6 days of vacation time. How many days per year does he earn at this rate? And in this section, everything we're going to set is going to be proportion form. So now you don't get to choose what form you're working with. You're going to start working with proportions, and they're going to work really nicely. So let's take a look here. What are we comparing in this case? What are the two different quantities that are being compared? Okay, days of what? Days of vacation. So we've got his vacation days. And months of what? Yeah, months worked, right? It's actually the months he worked. So if he were off sick for a whole bunch of time, then this might be something different. These are days he worked, the months that he has worked. Now you may notice I put the vacation days on top of the months worked. That makes no difference if you put it upside down. That'd be okay, because there's 621 that I just had on the board before, so I could have flipped it and put it over each line, right? Okay. So if this says that after 9 months working, he has 6 days vacation. So I've got vacation days. That's going on top of the way I've described this. I don't want to equals. I'm sorry. I've got vacation days on top, so that's his 6 days of vacation over how many months? 9 months. And what do I want to find? The number of vacation days for a year. So I don't know the number of days, right? So let's call this X days. That's what I'm looking for. What goes underneath X days? 12 months. And it is important, and it was mentioned earlier, and I'll mention it again, that my units stay the same, right? The question was how many days does he get in a year? And this is 1 year, but I needed in months because it was months over on the left-hand side. So this is 12 months. Now I can use that theorem that we had from the last slide, 620, to actually solve this. And I can do that by multiplying. One of my students last semester talked about this, and she described it as making a butterfly. Right, so that's the visual imagery that she created, which I thought was really nice. So we have 6 times 12 equals 9 times x. And you'll notice I'm not putting any units on in the middle of the work that I'm doing. I tend not to do that. But the reason I do this is because at the very end, I'm careful to make sure I put it back in at the end. The answer has to have 2 on it, but if your work between doesn't, that's okay. Make sense? Okay. 6 times 12 is what? It is 72 equals 9x, then what? Divide by 9. So I'm going to make this say x equals, what is 72 divided by 9? 8. 8 what? Days of vacation, right? So he gets 8 days of vacation a year. Does that make sense? We're going to do one more before I let you guys go, and then we'll finish this up next time. We've got a city map. Everything when we're looking at maps is always drawn to scale, right? So they scale things down so that the image sort of still looks relationally correct, but of course you know that when you look on a map, it's not the actual distance you're traveling. So on the city map, the rectangular park has a length of 4 inches. The actual length and width of the park are 500 feet and 300 feet, respectively. How wide is the park on the map? The first question is, what am I comparing? Okay, so you're comparing, and we can do that. So you're comparing the park on the map to the park, let's say in real life. Maybe like that. Does that work? Okay. What else are you comparing? The length and the width, right? So if I'm comparing the map versus real life as a ratio, then the length and the width are the other two comparisons. Okay, so how long is the park in the map? 4 inches, right here. How long is the park in real life? 500 feet. How wide is the park on the map? That's what we don't know. So we'll call that X. It's X inches, whatever it is, that's refined. And then how wide is the map, I'm sorry, is the park in real life? That's 300 feet. Does everybody understand the setup and understand that there's lots of ways that you could have set this up in my book reference? Okay, so let's cross multiply. Create that butterfly. All right, so I have 4 times 300 equals 500 times x. So what's 4 times 300? 1200 equals 500x. Then what? Divide by 500. Now, if you simplify this to simplest fraction form, it will say 12 over 5. Okay? The zeros will cancel. That doesn't seem like a very realistic thing to say to somebody, right? So what would you simplify this to instead? 2 2/5 or 2.4 probably, right? You probably would turn it into a decimal form. If you wrote 2.4 or 2 2/5, that's fine either way. 2.4 or 2 2/5 what? Inches. Either of those would be fine. All right, we'll pick this up next time.